We just studied slope and how we can interpret that slope a little bit as far as the graphical perspective. We're going to use that now to graph lines. We also, in this video, are going to write equations of lines. So kind of bringing together a bunch of pieces to do those things for lines. Okay, so we've got a little bit of explanation up here at the top. Really 2 points, any 2 points will determine a line, but it's best if you have 3, 4, 5, the more points you have, the more accurate your picture is going to be. So let's take a look at what we have here. This equation, we have f of x equals negative 4x minus 8. When I look at that, the first thing I think is my y-intercept is 0, negative 8, and my slope is negative 4. And I'm going to think of that negative 4 as negative 4 over 1. The reason that is helpful is because I have a point on the line, that y-intercept, so I can plot that. 1, 2, 3, 4, 5, 6, 7, 8 down here. So we're there. I'm assuming a scale of 1 here on this set of axes. And then we are going to use this slope. So I have 2 options here, just like we looked at in the last example on the last video. You can go down 4 and to the right 1, the down being the negative 4 on the rise. Positive run means I go to the right 1. Or I can think of that as 4 over negative 1. Right, all 3 of these, this negative 4 over 1, or 4 over negative 1, are all equivalent. And in that case, I can think of that as a positive rise and a negative run. So those are sort of 2 options for getting me some additional points. Let's use the first one, that negative 4 over 1, first. That means I go down 1, 2, 3, 4 spaces and to the right 1. I'm sorry, to the left. That's backwards. I was correct when I said right. I went the wrong way. The right 1. Okay. The other option is to go up 4 and to the left 1. So from that point I just drew, if I go up 4 and to the left 1, I get back to my y-intercept. If I go up 4, 1, 2, 3, 4, and to the left 1, I get here. I'm going to keep going just because the more points I have, the more accurate my picture will be. 2, 3, 4, and to the left 1. I really like having the x-intercept too. From that, I can see my x-intercept is negative 2, 0. 1, 2, 3, 4, and to the left. I usually go until I run out of space. Run out of coordinate plane. So I get that, and then I draw a nice straight line connecting those. I usually prefer to use a straight edge. That's not really possible on this tablet here, but that's not too bad. So that's our line. Negative 4 x minus 8. Remember, this is the same thing as y equals negative 4x minus 8 when you're in that function notation. Okay, so that's what is kind of described here. This up here talks about using points. I don't think that we need to just plot points. There's no value in that anymore as far as like a table of values. So using the slope description is kind of here. Let's do it again. Y equals 2x plus 3, if you convert that from function notation to the y-intercept, the slope-intercept form there. The slope is 2. The y-intercept is the ordered pair 0, 3. So I plot my y-intercept first, 0, 3. And then I'm going to remember this is 2 over 1, which is going to tell me to go up 2, positive, and right 1, or negative 2 over negative 1 is also equal to positive 2. So I could go down 2 and to the left 1. So from this y-intercept, if I go up 2 and to the right 1, I'm here. Up 2 and to the right 1, I'm here. Up 2 to the right 1. I'm going to keep going until I run out of plane here. Down 2 and to the left 1 to go the other direction. And there we have those points, and we connect the dots. Okay. It's not nearly as pretty looking. Notice I put an arrow on the end of each of these. That's because the domain of a line is negative infinity to infinity unless you're in real data and you're given some sort of restriction on that. There's no restriction on what we can put in, replace x with. Okay, so that's graphing lines. Let's talk about writing equations of lines. We saw the slope-intercept form is y equals mx plus b. You could see it in function notation, f of x equals mx plus b. You're probably very familiar with that. Usually by this time, students are pretty comfortable with lines. This question asks us to find the equation of the line passing through 2, -3 with slope -1/2, and then graph the line. One thing I did want to point out up here, since we're talking about slope and stuff, this line here had a slope of -4. That's a negative number. This line had a slope of +2, which is a positive number. Negative numbers are decreasing as negative sloped lines are decreasing as you move from left to right. Positive sloped lines will increase as you move from left to right because you're going up and right at the same time. So that is something to consider. Also, the bigger the absolute value of the number, so the absolute value of -4 is 4, the bigger that number is, kind of ignoring that positive or negative, the steeper the line is because your rise is much more than your run in those cases. So this is a much steeper line than this one where the slope is 2. And then to consider thinking about thinking about those different things that you're seeing, different slopes that you're seeing. Okay, find the equation of the line passing through 2, -3 with slope -1/2, and then graph the line. Well, we can graph the line without the equation, so let's go ahead and do that. It passes through 2, -3, which is down here. If the slope is -1/2, I'm going to think of that as going down 1 and to the right 2, or up 1 and to the left 2, if it's 1 over -2 is where that comes from. So from that point that I have, down 1 to the right 2 takes me here. Notice my slope is negative and my line is decreasing, but it's not very steep because 1/2 is a pretty small number compared to like 4, which was steeper. Now I'm going up and to the left. So there's my line. Notice I didn't need to have the equation of the line to be able to graph it. I had enough information without that. Now, one thing I noticed here, I started at this point 2, -3. When I went up 1 and to the left 2, it took me to this point 0, 2. That's my y-intercept. So realistically, I could pretty easily, from the graph of this, write my equation of my line, y equals, well, m is negative 1/2, and the y-intercept, oops, that's a negative 2, is negative 2. So I'm going to put that negative 2 in place of the b. Remember that b gives you the y-intercept. It also goes the other way. When you have the y-intercept, you can put that in place of b. So that is my equation of my line. Now, in this case, because that took me to exactly that point, 0, negative 2, I could use that. But what if that takes you to some weird fraction? You can't always rely on the graph to get you the y-intercept. We are going to do it algebraically. I'm going to show you how to get that equation of the line algebraically so that you're not relying on a graph where maybe that picture is not the greatest. Okay, let's go here. Y equals mx plus b is the slope-intercept form. This is one way to write the equation of a line. We know the slope is negative 1/2, so I'm going to put that in. The only thing I still need to write the equation of this line is the b. If I didn't have this graph, I wouldn't have that, so I want to figure that out. What I know about this equation is that every point on the line has to satisfy it. If every point on the line has to satisfy it, then this point right here has to satisfy it. And I can put those numbers in place of the x and y to find my b. So I'm going to put the negative 3 in, and the 2 in place of the x. And then I still need my b. Negative 3 is equal to negative 1 plus b. Add 1 to both sides. I get b equals negative 2. And then that has to go in this spot at negative 2 to give me y equals negative 1/2 x minus 2. So that's how I do it. One way I can do it algebraically so that I don't need the graph. I don't need to rely on the graph. Sometimes your b might be 2/7. You're probably not going to be able to easily see that from a graph. So that's why we want to have these algebraic techniques. Another option for graphing, finding equations of lines, is to use point-slope form. And this says a line with slope m passing through x1, y1 is y minus y1 equals m times x minus x1. This actually comes from this formula. Remember this formula for calculating slope? It's just we've taken the subscript off the y2 and the x2 and then multiplied both sides by this denominator. That's where this comes from. It's not really a new equation. It's just this old equation that we had before, written slightly differently. The x and the y are the variables. They can be any point. The x1 and the y1 is the point that you're given. The m is the slope. This form is not something that I ever used as a student. When I was a student learning mathematics, I never used point-slope form. I always used slope-intercept form. Y equals mx plus b, y equals mx plus b, y equals mx plus b, always. And that's okay. That's fine. You can use that. I personally think that sometimes it is easier to use point-slope form. So as a teacher, now I use it a lot. I use it in my calculus class when we're writing equations of lines because I just find it to be a little bit easier. When you're given a point and the slope, it makes sense to use point-slope form. Remember I said mathematicians aren't very creative in how we name things? Well, here's another example of that. Let's use point-slope form to write this same equation that we wrote above. Y minus y1 is equal to m times x minus x1. And we just plug in what we're given. Y1 is negative 3. M is negative 1/2. X and y stay as the variables. And x1 is 2. And then we clean it up a little bit. Y plus 3 negative 1/2 x, distribute, you get plus 1. Subtract 3 from both sides, and you get y equals negative 1/2 x minus 2. The same solution that we got before. So whatever your approach is fine with me. So sometimes I use point slope, sometimes I use slope intercept. It really just depends on the scenario. Okay, let's do this one. This one's a little bit different. It's asking you here to find the equation of the line passing through these 2 points. Up to this point in this video, everything we've seen, we have been given the slope, or maybe indirectly given the slope, because you either were given the equation, where you could pull the slope right out of it, or the slope was actually just given to you. What we know about graphing lines, writing equations of lines, whatever it is, you always must have the slope of the line. You basically know nothing about a line if you don't know its slope. So that is one thing we must always have. Notice we have slope-intercept form, you need the slope, and point-slope form. You need the slope in both of those. So in this case, when we're not given the slope, we have to calculate it. In some way, we have to figure out what that slope is. In this case, because we're given 2 points, we can calculate the slope between them using y2 minus y1 over x2 minus x1. 7 minus 5 over 2 minus negative 4, 2 over 6, or 1/3. Now we have the slope. We can pick either of these points. It doesn't matter. I'm actually going to show you both I'm going to use slope-intercept form using both of these just to show you that it doesn't matter which one you use, the ratios and things all work out to be the same. I actually prefer the second point in this case, just because there's no negatives to worry about. Y minus 7 is 1/3 x minus 2/3, and then we need to add 7 to both sides. I'm going to do a little calculation here. When you're adding 7 to both sides, we need to think of that plus 7 instead of plus 7. It's probably best to think of it as 21 over 3 so that we can add those. Negative 2/3 plus 21/3 would be positive 19/3. This is an example of one where you probably would not easily see the y-intercept of this from the graph. That's what, 6 1/3. It's not real clear when you're at 1/3 or if you're at 0.3, because 1/3 is not the same thing as 0.3, right? So you have to be super careful trying to use the graph. Unless you go to a known number there, then you probably want to avoid using the graph to find the y-intercept. I'm going to do this exact same process over here, but with the other point, the negative 4, 5. 5 goes in place of the y1, so over here I use the 2, 7. Here I'm going to use negative 4, 5. Just to show you that it doesn't matter which one you use. Slope we calculated to be 1/3 x minus negative 4. So we have y minus 5, 1/3 x. That's going to be plus 4, and then when I distribute it, I get plus 4/3. Now I'm going to add 5 to both sides. And remember that we don't really want 5 to be able to add 4/3. We're going to think of that as 15/3, which gives us y equals 1/3 x plus 19/3. Same result. Whichever way you go, it doesn't matter which point you use in that point slope form. You could also use slope-intercept form here. Y equals mx plus b. No problems there. You would get the same result. Okay, let's take a look at using intercepts to graph a line. We want to have different options depending upon what information you're given. You may want different choices. So here you are given f of x equals 3x plus 8. I'm going to write that as y equals 3x plus 8. Typically, I would just use the slope and the y-intercept, plot the y-intercept, and then use the slope to graph this line. But this specifically asks us to find the x and y-intercepts. We're going to do that. The x-intercept is where this graph crosses the x-axis. That point, no matter what it is, has to have a y value of 0. So I do that. The y-intercept is where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. Any point on the y-axis has x value of 0. So when I'm looking for my intercepts, I tend to do this kind of table of values and then figure it out from there. When y equals 0, I get 0 equals 3x plus 8. Negative 8 will equal 3x, so x equals negative 8/3. Remember, this is 1 point on the line. Sometimes students will just set equations equal to 0 because they're not sure what to do. This is only giving us one specific point on the line. It's giving us this point. This is negative 2 2/3. So 1, 2, and 2/3, if we're going by ones here, is going to be about here, negative on my x-axis. Now let's do the y-intercept. Y equals 3 times 0 plus 8. Y equals 8. That should not be a surprise to us because that 8 is what we've always used as our y-intercept. 1, 2, 3, 4, 5, 6, 7. So now we have this point, the y-intercept. We have the y-intercept and the x-intercept. 2 points are enough to determine a line. So I'm going to connect my dots here. Ooh, that's not a super straight line. Where is it? That's a little better. There we go. All right. So there's your line. Even that end of that tail that I just drew is a little crooked, right? That's why I like more points than just 2. But here, this is what it asked us to do. Okay, that's our intercepts. We have a lot more to study on slope. I think this is a good point to stop this video, so we'll come back to look at a little bit more on slope in the next video. Take a little break. Enjoy.